So thank you all for being here. I will try to make it simple because it's not important, but it's going to be way more. I can detail if someone wants to have more details at the end, but right now I will try to make it as simple as possible. So first, I would like to explain the passive house context. So one of the five passive house principles is regarding windows and exterior shadings. So today we'll explain one of them, half of this one, exterior shadings, and why we do that. Why? It's because controlling solar radiation is key to prevent overheating in passive buildings. All buildings, and especially passive house buildings, can take advantage of smart shading devices when needed. Obviously, you can have a great advantage of using shades when in summer times, but also winter. Depends on what you want to do, where you live, and that's gonna be able to demonstrate here. So there is a sentence I want to just explain. The sun can't be controlled, but it can be managed. So that's from Angelique Rinkhoff, which is the CEO of Varema. As you can see, Doug was not really Doug said it was not going above 144, but 45. But yeah, actually, we never know what's going to happen in the future. How we can know how much energy goes into our buildings through the windows? Well, we do simulations. Simulations of the energy model per climate zone and per building can help us to identify when we need to have exterior shades or not. Here, if you can see the map here, we are not equal when we are looking at the solar energy coming from the sun. So in California, especially in the south of California, southern California, we are much more sun than needed, especially at the end of the summer when it's already very hot. We don't need this extra energy, and we need to find a solution to fight it. And you can see that we are not equal. Even in California, there is 16 zones, if I'm not mistaken, with different climate zones. So make sure that you apply these zones for your calculation simulations. So the reason why I wanted to present today is because 2 months ago, I heard from Matthew Bowers, the director of building science in our group, that they now find a way to prove that external shading devices are very important. So he presented, so that's why I'm taking slides from his webinar he presented to you 2 months ago, integrating passive house with multiple family. He was showing us with simulations on windows that he can calculate the amount of shades in front of each of the windows in the buildings. So he's taking everything into account, the position of the building, the facade orientation, everything, and then put every single data in the PHPP spreadsheets. And how he found out that we need exterior shadings? Well, by the results. He presented 4 examples of passive upgrades. So at San Jose, San Diego, Los Angeles. And obviously, it's different, like I said. But if we focused on Los Angeles, improvements needed to achieve passive house performance is obviously windows, heat recovery system, airtight buildings, and the new thing is exterior shading devices, which is not obvious when you're a passive house consultant or things like that. So that's why I wanted to show you that we demonstrate now that simulations, using simulations, that it's very important to understand why. I'm trying here to present this as simple as possible. So I created this diagram here showing the shading devices available and a classification per energy efficiency when they are used intelligently. So here, not efficient, 5% only of energy eliminated by adding a shading device. So that's almost nothing. To very efficient solutions, but removing 80% of this energy. So now I will explain. So curtain drapery, that's the worst of the worst. Obviously, curtains, especially when they are black, so you can see that from black to translucent or white, you have different performance, obviously. But the worst of the worst are curtains because they can absorb all the energy and then we send this energy inside the building, inside the rooms by infrared. So that's not a good one. Interior Venetian blinds also are very common, but they are not efficient either, especially if we have black slats. So as you can see here, the color is very important if you are choosing a color for interior in terms of performance. If it's black, it's going to be bad because it's going to absorb more energy than white. So that's why you have a wide window here, because black slats are not good. Wood color, I would say wood or color that in the middle, yes, in the middle, and white aluminum is the best, but it's still not very efficient. Then you have interior roller blinds, and the same thing here. It's even wider because they developed somehow sunscreen fabrics that are made to prevent as much as possible overheating by adding a coating with aluminum on the fabric to have them reflecting all this energy as much as possible. But as you understand, when we have passed the double pane window, it's too late. The energy is already in the building. So that means that we have to make sure that we prevent this energy to come inside the building. So black is bad, white, it's okay. I mean, it's not okay, but in terms of interior roller blinds, it's better. And obviously you need to use sunscreen fabrics, and they're not cheap, they're expensive. So they are not super efficient and they are expensive. Then I placed here all the other devices, all the exterior roller blinds, zip screens, awnings, sunsets in the same square here. Because for me, they are all likely to do the same amount of energy savings. Obviously, colors is important, but less important. It's more the distance, I would say, with between the protection and the window, which can be important. If it's too close, it's going to create some of buffer with a lot of energy in. So that's already something that it's more efficient. So as soon as you use exterior shading device, it's efficient. Then you have the roller shutter, which is not very common here, but it's also more efficient. Why? Because you have insulation. Each slat can be insulated. So if it's made with plastic, you have air between, so which is good for insulation. And if it's made with aluminum, they put some foam inside, which is good for insulation, but I would not recommend to do that because environmentally, it's not good to use foam. We all know that. And then the most efficient solution ever, and can't be beat by anything, it's external Venetian blinds. Because actually, when you use Venetian blinds, it's literally like having small overhang on top of each other, and you can control the slat orientation. So that means that you can keep the blinds all the way down when it's sunny outside, and you still have natural light. You just have a slat oriented to have a cutoff position, and then you're good. And obviously, I will explain why also in the next slides. Common ideas that are not applicable in certain climate zones in California are adding an overhang, because sometimes it's not efficient enough, I would say. an overhang can protect you from the summer. Obviously, the sun is not gonna go inside, but as you know, overhangs are made to also leave the sun coming through during fall and winter, which is good for winter, but not in fall. And as you can see here, where's my? Oh yeah, here in September you have already partial sun inside your room, but in September it's also a month which is the hottest month in California. So that's not very useful. So cons also, it can't be used when the property limits is reached. You need to add a solution for privacy, and that doesn't work on east and west facades. And obviously, like I said, doesn't avoid overheat at the end of the summer and fall. So to replace the ID, so sometimes you install roller blinds, saying that, well, what's going to work with an overhang and a roller blind, interior roller blind, that's going to work. I would recommend, instead of using these two devices, to use the external Venetian blinds, because with a slat tracking automation system, you can easily control your glare, your natural light, and then having everything that you need. So as you can see, when the sun is very high in the sky, the slats are almost horizontal. And when the sun is low, the slats are tilted to a perfect angle to have a cutoff position. So it's why I called active solar design instead of passive solar designs, because sometimes it's important to know that you can't do it all on your own. So you have to let the systems take control of your shades. So very quickly, I will explain some scientific stuff, because I just want to explain the details a little bit. Solar heat gain coefficient, it's the amount of energy passing through everything, going into your room when you have the sun at 100% at the end. So that means that the solar heat gain coefficients can clearly give you an indication of how you're going to perform in terms of solar protection. So here you have 100% of energy coming from the sun. If you have a double pane windows, 30% of the energy is reflected, and then you have 46% passing through, with also the absorptions and the re-emission inside. That means that you go to 58% of energy passing through a double pane window, which is a lot. If we do the same simulation with Venetian blinds, well, the numbers are way more different. Okay, all the details here. You go down to 12%, which is reasonable. You can even add a roller blind inside to go to 4%. But that's not the purpose of this presentation. So I will just explain that choosing the right shading device is going to prevent overheating a lot. So if I compare this interior roller blind, which is made with the aluminum fabric to reflect as much as possible of the energy outside, you go down to 35%. So from 58, you go down to 35%. Versus external shadings, external Venetian blinds, you go down to 12%. That means that it's 3 times more efficient. And to be honest with you, I know, because I'm aware of the pricing of these products, they are almost the same. Like I said, the fabric for roller shades, roller blinds, if you want to use a very efficient fabric, it's going to be expensive. And the external Venetian blinds, well, they're made of aluminum, so they're not cheap, but they're not very expensive. And we can have also a simulation that can explain how much energy you're going to save at the end of your project. The next thing is I wanted to explain a little bit more about automation system. Like I said, it's very important to be sure that you don't have to do anything. Even if you're a homeowner, if it's a commercial building, obviously you don't want people to move the shades on their own. So it's going to be automated. And obviously with external ventilation blinds, it's easier to control the glare and the natural light. So which is perfect. And here, every single system, you have the annual solar path in their core, I would say. That means that you can automatically tilt the slats. So the same day of the year, if the sun is very high, the slats will be almost horizontal. And in winter, the slats will be almost at 45 degrees. So yeah, to prevent you to have direct sunlight. This doesn't mean that if in winter the day is very cold, we can't do that. We can't remove the slats to be on the way and then have energy coming in. I will explain a little bit later. The second automation system that is available in a complement of what I just explained is sun tracking system, I would say. Slat tracking can be activated automatically when the sun rises. Okay, so the blinds are down, the slats are tilted to 45 degrees or less, depending on the position of the sun in your sky. And then during the day, the slats tilt automatically to adjust their angle. Okay. And then if if you have shades, clouds on the sky, well, the system can react automatically, put the slats to an horizontal position or and shut off the slat tracking system or retract the blinds. It's up to you. And the same thing can happen with some buildings in front of your own building. So in the shadow, the tilt can slat to horizontal or retract. That's exactly what I will present on the next slide, which is active facades, which means that we can simulate the position of the sun, and we have an emerald shading diagram. So the shade in the building can be controlled, programmed to raise when it's not necessary to have control of the sun. So that means that these three will be in cutoff position, but these three will be automatically open because there is no sun. And it's fully automated. You don't have to do anything. So now I will let Christian present his house and what's in there. Christian?
Yes, if you can operate then the slides, that would be great.
Yeah, no problem.
We did our home here as a passive house standard. Since I'm originally from Germany, passive house was on the radar for a long time, tried to convince clients to go this route, and nobody wanted to go 7-8 years ago that line when we started planning for it. So we decided to do it for ourselves here. Today, I would like to just speak about the exterior shading. Passive house had the stigma when we were planning it, especially when looking in Germany, that the windows are very small. You cannot have big windows. And here in Southern California, if you're working as an architect with the weather, everybody wants to have large windows. Everybody wants to have the outdoor-indoor living experience. So small windows was not an option. We needed to go to large open windows, and the shading came into play. Actually, in Germany, it's very common that buildings have exterior shading. Even though there's not much sun, most of the time the weather is gray and the people are grumpy. And but we have a lot of exterior sunshades, as Cyril had mentioned. So it was a no-brainer for us to go and look into exterior sunshades. But a couple of years ago, we had a hard time finding them here 6-7 years ago. And that's how we connected actually with Cyril. that he was one of the few ones who was offering them. It was interesting. Some American companies offer them in the South American market, but not in the US market. And since it was a common product, we said for our building, here's a picture on the left-hand side of the master bedroom and the office, and the office I'm located in right now here. And go back, Cyril, not too fast. I gotta go back to this one. So the part was, no, on the next one. With that one, yeah, stay here a little bit. So the part was also that, let me explain quickly how it works. We see the roof sensor. We have the sensor on the roof. That one is connected to the actuators. Our building has 2 zones. The upper floor is 1 zone, and the lower level is 1 zone. And the wires go to that one. Then each blind has an integrated motor, which we see in the next image here. You need a power supply at the window, and you have a control panel. Those are all the 4 elements you basically have. And on the exterior, you have the blinds. There are 2 different systems existing. It's one is a cable guided ones. It's on the right-hand side, and we have the channel guided ones. The channel ones are a little bit more stable, but in the end, they work the same, and where you have no options for installing the channel because it's a connection of 2 blinds, you can use a cable one and they're almost disappearing. The blinds have different shapes. There are different options and shades here. We have just a very simple aluminum shape. They're around 4 inches wide, and they're completely controlled based on the sun. I use them also as privacy. We don't have any curtains in the building. Mostly comes from it that I had to wash the curtains of my grandmother and as a child, as a teenager, and I really hated that part of it. So no curtains, we use it as privacy shading. The exterior blinds have another advantage for privacy because at nighttime, so a lot of exterior roller shades you can look through when the lights are on in the building, and they don't provide the privacy. But with the exterior blinds, when they're closed on the outside, you cannot look inside, and they basically act as curtains. One part when installing them, which is a question which came up, and it needs to be connected to the fire alarm system. So if the fire alarm goes on, they automatically retract so that you uncover the egress windows from bedrooms as required by code. And the blinds are completely controlled by the sun angle. So if you have a day where there's overcast and clouds, the blinds are just staying open. And if the sun is shining on the west side, they're going down on the west side, or they're retracting on the east side. And one other advantage why we chose that system was it gives you the opportunity to still look outside. With exterior roller shades, you have the textile down and the view is obstructed. And with these horizontal blinds, you can still look through the system and you get an exposure to the outside. It's a relatively low tech system after you understand it, and it works very well. We have it installed now since 5 years and had no issues with it. It works perfectly fine. Go to the next slide. Next slide. If you we did actually a study that was a couple of years ago, got an award also for it. Cyril and the company, they did a study how much energy was saved per year. We're at 19 kilowatt hours per year saving, which is significant. That helps on the air conditioning system. Next. And here are some images of how the blinds, large glazing areas here, that's the blinds on the cable system. Next. In the living room, that's where you see this hybrid where the blinds are on the horizontal level. It gives you the sun shading, but at the same time, you still get the view to the outside. Maybe more significant on projects where you have maybe ocean view or mountain view so that you can still see it, but it's still the indoor-outdoor connection was important, and you will never see a hard shadow or the hard sunlight inside the room or on the floor. It's always cut off and it tilts automatically. Next.
Yes, and just wanted to add that here you have 3 blinds. One is the larger one to cover the fixed windows, and then 2 small ones to cover the open windows. So it means that you can have them partially down and have control of the blinds on the center.
Correct. And at the doors, we have an override switch. So when you want to walk outside, you push the button and the blinds at the door just retract so you can access the building. You don't have to open the entire facade. Here, another detailed view. This is the cable guided system, as we mentioned earlier. And the slats are slightly tilted. Next one. Next, that's just a general one that doesn't show much blinds. And here's another view of the blinds where we saw it from the inside of the living room. Again, the large facade in 3 segments, and the 3-foot door opening can retract so you can come in and out of the building. In terms of maintenance, didn't have any maintenance issues over the last 5 years. They have a wind sensor protector, which actually got triggered last weekend. We had the Santa Ana winds here. And if the wind speed, I think, goes over 40 miles per hour in gusts, the blinds automatically retract. We had that in the last 5 years, maybe 4 or 5 times. And that's maybe a little bit an inconvenience at nighttime, because at nighttime, if you hear that there's a storm coming, then you hear the blinds retracting. But it's a very rare occasion that the wind sensor is getting triggered. But beside that one, the system works fully automated. If you're on vacation or not, it keeps always the sun outside and closes the blinds. It has another nice effect on the building. There's movement. So if you're traveling, if you're on vacation, the blind's still operating, and it appears somebody is at the building as well. So it's from our experience over the last 5-6 years, a great working system. And it made the combination between very large windows and the hot temperature weather here in Southern California possible. It's so we happily answer any questions from the practical operation part.
There is a question in the chat. Here it says, are a life cycle design. This is from Tom Phillips. What are some examples of designing and shading for future climates and urban heat, and estimating the life cycle savings?
Cyril, you want to mention the lifetime? I think there were some studies on that one. I mean, I can just briefly say in Europe or in Germany, my high school, my elementary school, every single building had office buildings has these blinds, and I think they're calculating them for 25 years or 30 years, or even longer. They're operating in it, and it's just a very, very standard long time product. I know the comparison, Europe has a different sun exposure, it's maybe less harsh than here in Southern California, but you might have some more data on that, Cyril.
Yes, sorry, I was just trying to figure out how to remove a share screen. Yeah, actually, I have some data from Europe, obviously, because they have these products for more than 60 years. So that means that they know what they are doing. The slats, they are made of aluminum, they are powder coated. So that means that they're going to stand forever without any issue. Also the cables, they are made with stainless steel covered with some specific coating. So that means that it's going to stay also for a very, very long time. So there's no issue on the materials. And the motor is also well protected now. They figured out that they needed to implement a thermal break. That means that if the motor is overheating a little bit, it's going to stop to cool down for a couple of seconds, I would say, and then restart again to work. So that means that you don't even have to worry about burning the motor or everything in this kind of products. I have an example. When I arrived 9 years ago, I was asked to replace the blinds of on Pacific Palisades. They were 22 years old, which is, I mean, in California, which is very very good, I would say. And they were working great. The only problem is that the color started to fade a little bit, I would say. And some, because it was with guide rails, so that means that you had also some nipples at the extremity of the slats. and some nipples were somehow starting to fail. But the blinds was completely operational. That means that after 20 years, I'm very confident that the blinds that I'm installing right now, they're gonna work great.
There is another question, or the next question is how quick from Ian is how quickly do the blinds retract?
Depends obviously on the height of the windows, but I would say a regular size of a window is gonna take 1 minute, 1 minute and 30 seconds max. And yeah, it depends on the width also, because the more you add weight on your blinds, the more the motor is gonna have to slow down to be able to retract everything.
I think you showed me the high-speed blinds. I would guess maybe my 9-foot tall windows, I would guess maybe 20 to 30 seconds.
Yeah.
I think it was pretty, it's not much faster. I think it doesn't take so long.
Mm-hmm. The next question is from David Edwards, and it's a double question. What is the cost of the systems? And how do you get the window by window control of the blinds with a rooftop sensor?
Well, actually, so the cost depends on plenty of factors, because the slab design, the colors, it's also very important, and also the automation system which is attached to it. The blinds by themselves, they are not very expensive compared to regular roller blinds. They're probably 20-25% more. But if you add the automation system, you have also a percentage of it that you have to understand. It's to have a fully automated system, and it's gonna cost also, I would say, depending on the automation system, between $200 and $400 per blind. And then you have full control of your blinds. And per window, you have multi-channels. So that means that you can have one remote to control all your windows with multi-channel remotes, or the same thing with your app on your phone. You can control them independently, or even with your browser on your computer, you can control everything. I mean, everything is controllable with your computer now.
To add on to the control, the blinds are controlled. You can control them individually by the control panel, which I had showed in one of those slides. And the blinds are actually combined to the facade. So the west facade operates as one, the south, north, and east facade, at least in our case here, since it's a simple box. And based on the sun exposure for each facade, those are combined. But it's as I understand it, it's a programming question, and you can adjust the programming, and you have some flexibility in that part.
And I would also add to the weather station. It's gonna control everything, because the weather station, there is an orientation. You have to place your weather station in a direct way, so you knows not only the speed but also the direction of the wind. And also you have 4 sensors on the weather station. That means that you know exactly how much lux are coming from which side of the building. So you can actually, with all this information, control individually all the shades, all the blinds.
Thank you. Another question from Bronwyn is, Christian, can you give some idea of what the cost of the systems were on your project?
I gotta look into that. I don't remember the details.
Cyril,
do you know those?
The question is generic. What are the approximate costs for the blinds?
What is square footage? What does square footage cost? Do you have some current numbers for square meter or square footage?
That's a problematic question, because each time people ask me for a square foot price, and I would say, well, it depends on the size of window, because you have to understand, if it's a small window, it's gonna cost $2,000 for a small blinds. But if you have a huge window, it's gonna cost only $3,000, because the difference, it's the manufacturer. It's gonna be made automatically in a process, So that means that you have to understand that there is a motor, there is also other parts that come in. And the only difference between a small blinds and the big blind is the amount of aluminum you have. So that means that it's not progressive at all. So that means that a small window is gonna cost much more per square feet than a huge one.
Thank you. The next question is from Indu, and his question is: do you have any comparative studies for the effectiveness of the window treatment versus deciduous landscape?
Actually, not in the US. There was some studies in Europe, and the problem, yes, is you have also to select the right trees to be able to consider that if you want to use the blinds also, because I didn't talk about the winter position. With this external Venetian blinds, you can also control the slats to let the sun pass through, actually, the slats. So it's the opposite. You want to have energy, you have a temperature sensor inside the control panel. You have the comparison between the comfort temperature you need, and then, well, when it's too low, the slat will tilt to let the sun go through, and then to heat the floor, and then all the furniture inside, and then when it's at the right temperature, go back to horizontal or to the cutoff position.
Actually, design pH shading study should be able to help you out to evaluate what's maybe the better bang for the buck, planting a tree or buying blinds.
Yes, exactly. And the problem, yes, trees are very important too, but sometimes it's difficult to know how much the tree is gonna grow, how they can be pruned and things like that. So the amount of energy from a simulation point of view, it's complicated, more complicated to simulate a tree than
Of course, I totally get that, and it's a curiosity point because in California, in single family home retrofits or in situations where even you're building from scratch, you often have site landscape to consider, and sometimes it might be worthwhile as utilizing an existing element as a design consideration, as a cost savings, I totally get that it doesn't give you the level of control that a mechanized smart system does. So it wasn't sort of apples to apples in that way, but I was hoping there were some numbers for like solar heat gain coefficient or albedo or something.
Yeah, that's very complicated. Yes,
trees.
the most advanced person that can talk to you about it, it's gonna be Matthew, because he's actually doing all the simulations. So if you remember on the slide I showed from him, he was considering a tree in front of a building, and he was trying to simulate the tree impact, the impact of the tree on the shadow on the different windows on the building. And
actually use design pH. That was design pH, and design pH allows you to do this. The study, it depends how well you're modeling it, and then you can do it, calculate, analyze it for each window and bring it into the PHPP, and you can consider it, yes.
Yeah, that sounds great. I tried to do a similar study for like the fire risk on a parking structure with a green wall. So I do know that there are catalogs for how many leaves every types of trees have, but just translating that into a software seems like an enormous task. So I was hoping there was somebody else had done it so we could use it. Thank you for your time.
Thank you. There's another, we have 5 more questions. That's about all we can handle with the time that's here. The first one was, do you make any changes to the glass properties? Do you make any changes to the glass properties if you're using the blinds? Because California code probably requires a very low solar heat gain coefficient.
Yeah, that's one of the problem. That's why right now we are trying to use in the Title 24. There is also an extra page. I can share it with you. So if you give me your email address at Gian, I will share what I have found, because you can actually use less performant double glazed window in terms of solar heat coefficient, and then use the blinds to go down again to the value that is needed. So I faced this problem before, and we found a solution.
Thank you. The Germany and other European nations, from Tom, have overheating standards for new construction and for future climates. Have you dealt with those standards in any way?
You mean in California or in?
I think so. Yes.
Yes. Well, that's also the same thing. Sometimes they ask me how we can use your shades to put in the Title 24 to be sure that it's integrated in this. So we found a solution a couple of years ago, and apparently nobody is complaining about it. So that means that you can use the exterior shading device on the simulation for your code.
And PHPP limits the overheating days too, right?
Yeah.
The next question has to do with who are the manufacturers that you can recommend. Are they U.S. or European? And I'll put not my answer to it, but just so you know, if you go to passivehousecal.org and go to our sponsors page, the CPHBA logo that's there is a hyperlink to the company, so you could learn more that way. But are they U.S. or European manufacturers, Cyril?
Nobody in the U.S. can do that kind of things in terms of. We tried to have a company was doing it in the U.S. We figured out that it was even easier to bring the stuff from Europe. It takes more time, but that's less expensive to create the products in automated lines of production. There is 60 of them in Germany, so they know what they are doing, and then ship a product here. It's way less complicated than having a new company here to try to create these things.
Thank you. Is the controller an open API system, or for the controller, is it an open API system?
We have different interfaces to be controlled by Lutron, Crestron, etc., because actually I'm working on a project, very big project. There is 2 interfaces I need to create with Lutron. By the way, Lutron doesn't control very well external venetian blinds. And there is another layer with Crestron, which is way more smart, way smarter solution to control everything.
Thank you. I think we're going to, well, this will be the last question, is with regard to how much solar heat gain can external shades eliminate in San Francisco high-rise apartment with a 75% clear glass exterior walls and no mechanical AC or cooling?
Ooh, a lot. I don't know right now, but I heard how many. That's a lot for sure. It's gonna save you a lot of energy.
And we have 2 or 3 more questions, but we're out of time really. So I'm going to jump to the conclusion, but we can leave it on after the conclusion, after the concluding remarks. If Christian, if you and Cyril can stay and continue answering the questions, they are in the chat. But so that we have the sort of the end thing for everyone, let me quickly share my screen here just for a little bit, and we'll jump to the end, and then we can continue with questions for those who want to stay and have them. So we're back to seeing the call to action. We have the little fuzzy fellow there running away from us as it. When we have done studies on what does it take in a community or in an area to drive passive house success, to really accelerate the passive house success, you need to identify the leaders, set higher targets, support front runners, educate everyone, remove the barriers, reduce incentives, and then pilot projects. When people get inside a passive building and get to experience it, it's really important. So in terms of things we'd love for you to do, if anyone on here knows of an organization or group that might benefit from learning more about Passive House and the building blocks, if you could go to info@passivehousecal.org with your question. We have the board members and others located across California and are happy to help that in any way. If you are aware of any pilot projects or buildings that are in the early stages of planning to decide whether or not or how they can do this, again, let us know if you think there's places where we could make contact and it would matter. And then If you'd like to, if you support Passive House, if you haven't signed up for the newsletter, here, let me one more click and we'll get the passivehousecal.org. You can sign up for the newsletter. We have individual professional memberships. We have company memberships, sponsors and donors and volunteer. And again, at passivehousecal.org is where you will see those.